it, calculate, etc., etc. So now please feel free to choose. Anything.
Can we do question 6?
Okay, 6, and who? What else? Somebody else chose something else?
10.
Okay, so we have 6 and 10, so let's look at 6 and then 10. Good. Assume that a simple random sample, this is a key. Very important because the randomization is required. Has been selected and test a given claim. Okay, use the p-value method for testing hypothesis. Fine. Identify the null and the alternative. Yes. P-value and state the final conclusion. Yes, yes. The ages of actresses when they won an acting award is summarized by the statistic. I have to copy this. So n equals 82. X bar 35.9. S 11.1. Alpha 0.05. Here's the claim. The claim that the mean age of actresses when they win an acting award is 35 years. So, okay, I don't know how my mouse just went directly there. Obvious. So now they call it age 1. Okay, fine. So the mean is 34 and the mean is not 34. It doesn't say has increased. Using it to test the claim that the mean when they win is this. So since there is no keyword that says increased or decreased, we have to stick with not equal to. There is no other alternative. We can't use this because I cannot use not equal to in the null. I cannot use greater than or equal to. I cannot use less than because it doesn't say. So the claim is then when they win an acting award is 34. Not lower, not higher. So this is not equal to. Another two-tailed test. Identify the test statistic. Okay, so now one option, stat, tests, right here. Number 2, t-test with statistics. We have the mu0. If you see mu0, it must come from the null hypothesis. Okay? And that was, if you remember, 34, I'm sorry. I was still thinking of the previous one. 34, yes. So 34. Then X bar, I have it, is 35.9. I have this standard deviation, 11.1. I copied it. Sample size, 82. And yes, that's what I want, not equal to. And yes, I would like to draw. I want to see the whole graph, and I want to see the p-value. And I'm going to graph. Nice. Huge p-value still. So the test statistic, t statistic coming from this sample is 1.55. The p-value is 0.125. We know right here, right now, what is the relationship between this value and this value, which is alpha. Which one is bigger? I know it's a silly question.
The p-value.
Very good. What do we conclude right away? Every time the p-value is greater than alpha. So here's the graph, just for everyone to understand. Here is alpha of 0.05. But here is the p-value. Well, it's for two-tailed tests, so you know what I mean. I have to divide this by 2. I divide this by 2, and I divide this by 2. But you know, the idea is, look how bigger the p-value is, and this is the t-statistic. So it's in the non-rejection region. It's not inside alpha. It's not here or here to reject. So we fail to reject. There is not sufficient evidence to conclude that it's different. Three decimal places. Well, I can't. I only have 2. They should be happy with 2. Okay, identify the p-value. We did. 4 decimal. I can't. I only have 3. Sorry. Okay, so p-value is huge. Which means the test statistic fell in the non-rejection region. So we fail to reject either A or C. There is insufficient evidence to warrant rejection of the claim that the mean age of actresses when they win the first such and such 34. Let's also read C. There is sufficient evidence to warrant rejection. No. Good. So we wanted to continue with 10, and then we choose something else, of course. Okay, so let's take a look at the credit score. Used by credit agencies such as mortgage companies and banks to assess the credit worthiness of individuals. Fine. This is, by the way, a very nice field. If you're interested, there is a lot of work. A lot of companies need this field and need people who can do analysis for them. Car insurance or any type of insurance, credit card companies. This is a very interesting position and job if you're pursuing this career. I recommend it. Values range from 300 to 850 with a credit score of 700, considered to be a quality. Okay. According to a survey, careful, okay, we have to assume maybe that this is random. The mean credit score, I have to write it down. So this is X bar, 700.9. A credit analyst wondered whether high-income individuals' incomes in excess of, okay, had higher credit scores. Higher, so that's a keyword. He obtained a random sample of 40. Okay, so N equals 40. And found the sample mean credit score. Okay, so that's the sample mean credit score as 711.1 with a standard deviation S equals 80.8. Conduct the appropriate test to determine if high-income individuals have higher credit scores at the level of significance of 0.05. So now one more second. According to the survey, the mean credit score was this. So that is our mu0. Mu0 is 700.9. So this comes from a previous study. Mu0 is used, of course, for the null hypothesis and the alternative. Okay. 40, yes, okay. Okay, so we test the hypothesis. Alternative, null, and alternative. Null is that the mean is this from a previous study conducted whenever, and this is the mu is greater than 700.9 for these individuals. We will determine the test statistic, we will determine the p-value, and then draw a conclusion. Okay, so let's share again. T-statistic, so this is a t-test. And with the stats, yes, mu0, 700.9. X bar is 711.1. Standard deviation, 80.8. 8, sample 40, and I want more. I want this. And now I want to graph. T-statistic is huge p-value. Okay, 0.7984, and the p-value 0.2147. Okay, back to the problem. Okay, always equals. In this case, greater than, because you have higher credit scores. And the value given to us was 700.9 from a previous study. And the t-statistic, t0 or t-statistic, we got 0.79, 2 decimal places. Okay, so then if they want only 2, then I have to put 80. And the p-value is 0.21 round to 3 decimal places, 0.215. And make a conclusion. So let's make a conclusion first. Let's stop sharing for a second and let's make a conclusion. So this is the p-value, and alpha is 0.05. What do we conclude? We reject or fail to reject? Anyone? Very good, thank you very much. Every time the p-value is greater than alpha, we always fail to reject. There is insufficient information coming from this sample to say that this is incorrect. Okay? Okay, fail to reject. There is not sufficient evidence to claim that the mean credit score of high-income individuals is greater than 700.9. Good problem. Let's continue. Anyone? Any questions, first of all? Any questions on what we are looking at? Any questions, please?
Can we do 14?
Yes.
I don't have a question.
Yes, let's look at 14. Did you have a question before 14?
No, I didn't have a question.
Okay, perfect. So in the 2015 AFC Championship game, there was a change. No, I can't see well. A charge. The New England, okay, I didn't even, yeah, I remember that. The ball should be inflated to between this and this pounds per square inch. The accompanying data consists of 11 of the 22 measurements on their footballs. Complete parts A and B. Excellent. Okay. Test the hypothesis the population mean is less than. Okay, so first thing, I have the null and the alternative. So the mean is 12.5 psi, is less than, the keyword less than, so mu less than 12.5. Alpha 0.05. State clearly whether they were where the Patriots footballs are underinflated or not. Assume the conditions of hypothesis test are satisfied. So we don't have to worry about randomization and etc., etc. Okay? Determine the null and the alternative. So let's talk about this for a second. Let me just show what I just wrote. No change. That's always the null hypothesis. No change. And these were underinflated, so less than 12.5 psi. Okay, and we tested alpha 0.05. So now let's click on StatCrunch, and we go to T stats, T stats, one sample, because we're looking at one population. In the next chapter, the last chapter of the course, we're going to look at 2 samples, okay, but not now. With data, because we have the data. We don't have the summary. We didn't calculate the mean and the standard deviation of the sample yet. Okay, so we want to test, this is, oops, I didn't mean that. I meant 12.5. And this is less than 12.5. And we can put the significance level. It doesn't really matter. Okay. I selected the variable. Yes, I did. Compute. Okay, so I see. Look at that. So the test statistic, T statistic, is negative 11.237. There is no such thing, right? And the p-value is so small. Good. So let me stop sharing. So remember the test statistic. So for example, the sample size here, the sample size is 11. So can anyone give us, for n equals 11, how many degrees of freedom? Very good. Thank you very much. So when we're talking about something like this, it's basically really outside of even, because you know this is 0, right? So a test statistic, of course, this is the mean of 12, right? In this case, 12.5. But where will be negative 11? So that's why the p-value is so small. So the p-value is less than alpha, much less than alpha. What do we conclude when p-value is less than alpha? What is our conclusion when the p-value is less than alpha? P-value less than alpha. Yes. So apparently there is not sufficient evidence to conclude that they were cheating, according to the sample. Oh, I'm sorry, the other way around. So we reject the null hypothesis. So there is enough evidence to conclude that they were cheating, because we are rejecting the null hypothesis. So they were cheating. Okay, where is my problem? I hope it didn't disappear. Please don't. Okay, here it is. Okay, so less than. So mu equals 12.5, and mu is less than 12.5. The test statistic, we determined it. We got negative 2 decimal places. Okay, negative 11.2 decimal places, 24 then. And then the p-value round to 3 decimal places. 1, 2, 3. Since the p-value is so much smaller, the significance level, we have to reject the null hypothesis. There is definitely sufficient evidence to conclude that the population mean is less than 12.5 psi at a significance level of this. Using only the given measurements, it appears that the Patriots balls were definitely underinflated. Yes, they were cheating apparently, coming from this sample. Good pick. Okay, now it says use the data to construct a 95% confidence interval for the mean PSI for the Patriots balls, footballs. how does this confidence interval support your conclusion in part A? Excellent question. So now, 95%. Let's go back. I didn't use this. Okay, I used the StatCrunch actually, because I don't have the mean and the standard deviation. Okay, here it is. So now we want to go to stats, t-stats, one sample with data, but this time we don't want the hypothesis testing, but we want the confidence interval from you. And we compute. Okay, fine. We compute, and let me write it down. So here it is. Lower limit, 10.8714. Upper limit, 11.41039. Okay, and let's stop sharing for a second. So this is the 95% confidence interval. Look what happens. Is 12.5 in this interval? Anyone? Is 12.5 in the 95% confidence interval that we just determined?
No.
No, it is not. If 12.5 were inside the interval, we would have failed to reject the null hypothesis. But it's outside, right? Either here or here. In this case, 12.5 is up here, right? So the interval supports our conclusion from the test of hypothesis to reject the null hypothesis because 12.5 is not in the interval, which means their food bowls were consistently inflated under 12.5. If 12.5 is here, I cannot conclude. But the confidence interval showed that consistently their balls were food balls, they were underinflated. This is above. Completely outside of the interval. Okay? So this is clearly all their food balls were underinflated. I shouldn't say all. The confidence interval says that it supports the rejection of the null hypothesis coming from this sample. So then, where is the problem? Right here. So we have round to 2 decimal places. Okay, 2 decimal places, 10.87. And to very nice problem you picked, 11.41. Who picked it? Was Adriana? Okay, the confidence interval supports the conclusion in part A because the value of 12.5 is not, okay, is above the upper boundary of the confidence interval, or it's not in the confidence interval, it's above. Good pick. This was a very nice problem. Any questions on this? Any questions? So that's another way of